Okay, class, let's get started. Today we're talking about lines in a coordinate plane. The first is slope-intercept form. We have y equals mx plus b, where m equals slope, which we talk about it being rise over run, and b equals our y-intercept, meaning wherever the y or wherever the graph crosses the y-axis. So say for instance we have the equation of y equals 3/4 x plus 2. We need to first identify the slope and y-intercept before we can graph. The slope is the coefficient of x. In this case, slope equals 3/4, which means we will relate to it as rise over run, and our y-intercept at 2. Now the way that we graph this line, since this b represents my y-intercept, the graph will cross the line for the y-axis at 2. So we plot a point at 2. Then from that point, we are to plot a point that is up 3 and to the right 4. So 1, 2, 3, and over 1, 2, 3, 4. Now, if you recall, a -3 over -4 is the same thing as 3/4. So we too can also plot a point that goes from our y-intercept down 3 and back 4. And there too we can plot a point. Now, between those two, we can actually graph the line. And that would be the graph of our line. Of course, we know that it being a line, we would have arrows. Now, that's how we graph a line using slope-intercept form. We plot the y-intercept, and then from that point, we go our slope. Next form is standard form of a linear equation. The standard form for a linear equation is ax plus by equals c. A couple of stipulations we have to follow. A, b, and c are all integers. None of them can be fractions. A is greater than 0, meaning a cannot be negative, and both a and b cannot be 0. If it's 0, then we do not have a line. So, let's look at an equation in standard form. We have 6x plus 3y is equal to 12. Now the first way we want to graph this is by using intercepts. If we are asked to graph by intercepts from standard form, we have a couple of cheats here. One that I failed to write down is x-intercept. Now the x-intercept would be c over a. What does that mean? If we take an equation, 6x plus 3y equals 12, we want to solve for both x and solve for y. Two ways we can do that. We can plug 0 in for y and solve for x. If we did that, 6x would equal 12, x equals 2. And then also, if we wanted to solve for the y-intercept, we would plug 0 in for x. So that would give us 3y equals 12, or y equals 4. Now, on the y-axis, we can plot a point of 4, and on the x, we can plot a point of 2, and we can draw our line through it. And by drawing the line through that, let's see how good I can draw. It's not half bad. We see the graph. Notice that this graph crosses the x-axis at 2 and the y-axis at 4. Another way we can talk about is the cover-up method. If you've heard of it before, you cover up either the x or the y and you solve for the missing value. Now, how does these cheats come into play? Well, let's look at it. If I take 6x plus 3y equals 12. Notice that this 6 is my A, here is my B, and here is my C. So if I'm solving for the y-intercept, 12 over B, or 3. You know what we solved here? Yes, indeed. And so that is for the y-intercept. Also, if we look, if we're solving for the x-intercept, it's C, which is still 12, over A, in this case 6, which is what we got here as our x. So just a couple of helpful hints, aka cheats. Now, slope is negative A over B. We'll use that here in just a second. What if we need to transform a standard equation into slope-intercept? So let's take the following equation. We have 4x minus 2y equals 9. In order to solve to slope-intercept form, we're going to solve for y. So solve the equation for y. We're going to move it across. We have negative 2y equals negative 4x plus 9. We divide everything through by negative 2. So y is equal to 2x minus 9 halves. Our slope equals 2. Our y-intercept is negative 9 halves. So, which is 4.5, negative 4.5. So on my graph, I'm going to go down to a negative 4.5. And from that point, I'm going to plot a slope going up 1, 2, and over 1. And I can continue on if I would like, 1, 2, over 1. And until my heart's content. So from those points, I can now draw my line. And there's the graph of that line. Now earlier we talked about a helpful hint where slope equals negative A over B. I look at the equation where this is my A and this is my B and plug them in. I'm going to take the opposite of A, take what B actually is. Notice that I will get 2 as my slope, what I have already found out. What if we're given 2 points and we're asked to write the equation of a line? Say for instance, we are given our 2 points and a slope. We're told that we have the point of negative 1, 4 and a slope of 3. So using a point and a slope, we're going to plug those values into what we call point slope. Now, we know what m is. M is always our slope. Now we have 2 special values. We have an x-coordinate and a y-coordinate. But those values coincide with these values from our point. So all we have to do is plug in. So if we take y minus y1 equals m times x minus x1, simply plug in y minus 4 equals m, which is 3, over x minus a negative 1 changes to a positive. Now if we need to, we can simply graph. We can leave it here. We can transform it to slope-intercept or standard form, whatever of our heart's content. If you want to pause the video and try to solve for each of the 2, by all means do so. So here are our solutions. If we were trying to solve for slope-intercept, we would get y equals 3x plus 7. We simply, same as before, solve for the y value. Standard form, we would simply distribute first and then get x and y on both sides and make sure our stipulations are correct. A, B, and C all have to be integers, no fractions, and A cannot be negative. Of course, we would not have zeros here. If you recall, if you need to, remember, if this is a fraction, we can perform treble, top right and bottom left. If we need to graph, we have a point at negative 1, 4. It would be here, and a slope of 3. Well, it runs off. Well, never fear. Remember, if we have a slope, that's also at negative 3 negative 1. So I can go down 3 and over 1. Down 3 over 1. And I can plot that line for the graph. Now, what if we're given 2 points? Write an equation of a line given 2 points. Say that we're given the following 2 points. We have negative 2, 3, and 1, negative 1. We're going to first have to do a couple of things. One is we have to find the slope. Find slope. Because without the slope, we cannot plug it into our point slope formula. In order to use point slope, hence the name, I have to have a point and a slope. Now, recall, slope equals y2 minus y1 over x2 minus x1. Plugging in our values, this can be x1, y1, x2, y2. So I have negative 1, negative 1 minus 3 over 1 minus a negative 2. So we get a negative 4 over 3 as our slope. Now, when we're writing the equation, it does not matter which point we use. We can use either point, but we must use our point slope formula. So, plugging in our slope, we have negative 4 over 3 times x minus, well, I'm going to use the first point. So it's x minus a negative 2 and y minus 3. Now that's the equation in point slope. If our directions asked us to put it in slope-intercept form or standard, we would then need to solve. So for this one, I'm going to put it in standard form and show you how trouble, which I previously mentioned, works. Now, trouble, what do I mean? TRBL. I know it's not the way we spell it, but top right, bottom left. If I take this top number and distribute it to the right, I get negative 4x minus 8. And then if I take the bottom number and distribute it back to the left, I am essentially clearing fractions. So that gives me 3y minus 9. Putting it in standard form, get x and y on both sides. So negative 4 goes across, gives me 4x plus 3y equals, and then I'm going to take the negative 9 over, by adding it, 1. So that's the standard form for the equation of the line. And lastly, horizontal and vertical lines. And we have a lot of horizontal and vertical lines already on this graph. All lines that are going from, left to right are our horizontal line. The major one is this one right here, the x-axis. Then we also have vertical lines, this major one being the y-axis. Now, why are they so important? Well, understand that when we're graphing, that a horizontal line would be of y equals, let's say, 3. And that's the graph of that line, y equals 3. If we're looking for a vertical line, it would be x equals, say, 2. And that would be this line right here. Notice how that seems opposite. How the horizontals are going from left to right is the x-axis, but where does it cross? It crosses the y, so that's the reason why it has a value of y equals. And vertical, we can look at it this way. Now, if you also recall that a horizontal line has no slope, 0 slope, so its slope would equal 0. A vertical line slope is said to be undefined. Oops. Undefined. So we have a couple of, or a nice little saying that we can remember. Hoi vux. A horizontal line has 0 slope and it crosses the y-axis. A vertical line has undefined slope and it crosses the x-axis. I hope this helps you out. Look forward to seeing you in class.